Hello everyone. Today we have a technical session. This is Tech Talk 11. Just like the previous ones, we have arranged another Tech Talk, which is regarding designing data analytics and AI platform in Azure. The speakers are Rahat Yasir, Director of Data Science and AI, Microsoft MVP AI Canada, and we have another special guest who is Mr. Deepak Kaushik. He's an Azure architect and he is also a Microsoft MVP Azure Canada. So, hello everyone, hello guest, how are you?
Hey, thank you for inviting. How are you doing?
Yeah, it's fine. Hi Deepak.
Hey, hi, thank you so much for inviting.
So,
My absolutely pleasure.
So,
To
dear
talk.
audience and viewers, if any issues from your side, please let us know through the comments and everything. I think it's completely fine in the YouTube and Facebook Live, and I hope everyone can hear everything and can see also everything. So, I'm giving the floor to the speakers, and let's think this is your place and take the session as per your comfort. So, let's start.
Okay, thank you for inviting. Thanks to Microsoft Technical Community Bangladesh, because usually, like, we don't really get that much opportunity to share our expertise or like those data and AI new things that is happening all around the world. So we're happy to share all of them with my Bangladeshi audience. And please feel free to ask us any question that you have. We are not just like here to share some presentation and slide. We will try to like make it very interactive. So the way we were thinking to have the presentation is I'm going to present like a data and AI platform architecture. But again, Deepak is there. He is a very experienced Azure and data platform architect. He's also an Azure MVP. So we will make it interactive. So I will like bring some topics. He can also like share his expert opinion, and then we will take it forward with us. If I give a quick intro about myself, as I said, I'm the director of data science and AI at Isaac Instruments. It's been quite a few years working in this data and AI domain, and also building a lot of data and AI related products right now for transportation industry. So if anyone has any question regarding that, feel free to ask me as well. So what do we do? What kind of like AI we design for transportation, and what kind of like data analytics we are designing about for transportation? So the first thing is when we talk about data and AI, it's very easy to design something on a toy level or a smaller scale. But when we want to like build something on a large scale, we need to think of scalability, cost efficiency, and all the other big topics like how the AI will be trained and how the model will be retrained or that kind of things. For an enterprise, when they are setting up their data and AI strategy, they need to think more than just a database or an AI model or something like that. They need to think how this like model will be deployed, how can this model will be retrained, how this model, and what are the components that we need to have. So it's just a high level I just put a quick map for the audience to take a look. When we design data and AI platform, we need to build data related components. Our platform needs to have data related components. Our platform needs to have AI related components, and then our platform needs to also have platform like related supports. So for the data, we need to have proper tool so that you can do data ingestion in terms of like streaming, in terms of like batches, in terms of mini batches, something like that. When you do the data ingestion, we call it ETL, sometime extract, transform, and load. So you have a data source. It can be an API, it can be an FTP, SFTP, or any other type of or web crawling or connection to another SQL database. You need to bring data from the extract data from that source to and then transform it and then load it to your system. When you load it, yes, you can load it as it is, but also you need to sometime you transform it so that you can load it according to your need, based on the schema that you want to have, based on the way you want to use it. So that's why it's always important to choose the data ingestion process and tools very wisely. Then you have data storing. For sure, you have a lot of like options of you can store the data in blob storage, in Azure. There is blob storage option as well. You can also store the data into a data lake as a flat file. We call it ADLS Gen 2. You can store the data as a NoSQL data or SQL data, that kind of things as well, like Cosmos DB, MongoDB, or SQL. There is also like when you are loading the data, you also need to transform the data to make the data clean, processed in the right format, that kind of things. And the purpose of the data is to do reporting, visualization, identifying insights from the data, so that you also need to have tools regarding that within your data platform. And when you're consuming the data, you also need to have proper data consumer, so that you can host that much amount of data, scale that much, like the data overall operation. You are not hitting the wall in terms of like scalability, or like if the volume is big, you need to consider those things too. Then the metadata management, that is another like important like component of the data and AI platform. The reason is who has access to that data. Is that data secured or not? If there is any personal information or someone's name, email ID, driver license, or credit card information, if this kind type of information is there, are you anonymizing them or masking them before exposing it to the developers or users? Then data exploration, democratization, which is always important, because you want to give access of the like of your data to as many people as in your organization, so that they can do something with the data. They can come up with different types of like features. They can come up design different types of like tools or analysis or user based, user driven like opportunities. So you need to consider that one too. And at the end, the last one is data automation and code data quality checking. Having the data doesn't mean anything. The data needs to be of a good quality. The data needs to be well maintained, well checked. And the entire operation of data lineage, from ingesting to storing to metadata management to exposing like different types of like visualization, this entire process needs to be automated. If you're doing it manually, it's too much, because now you're thinking about one or two pipeline or one or two data sources. What if you have 500 data sources that are coming from different for different business domains? So you need to have that much automation in your platform. So these are the like a top 8 consideration you need to have when you're designing the data platform, data components for your data and AI platform. Then it comes the AI. Having AI, like designing AI, doesn't mean just designing a model. It is more than that. So you need to sometime you won't have enough data to train some sort of model. So in that case, if that platform is giving you the predefined model, all you need to do is take your data, send it to that model as a single JSON or single API request, and the model is going to like respond to you with the prediction. So it can be face detection, it can be OCR, it can be similar to like identifying some sort of like text analysis, that kind of like predefined model. For Azure, we have a cognitive service and also AI builder. A bunch of AI models are already there. All you need to do is connect them with your application and then use them as a RESTful API. Then the custom AI model. Yes, not all the use cases will be covered through predefined model. There will be some use cases where you need to build your own custom model as well. So either you train it from scratch or you use some sort of tools to train it. So how? So suppose AI builder has option where you can train certain types of model, like data extraction related model or form recognizer related model to train the form recognizer on your type of data structure or data format. So that kind of like custom model is also important. Outside of that, there is also like a custom ML for computer vision based model. If you want to design some sort of AI that will tell classification, image classification, whether there is any defect on this specific image, or like it can be a mechanical defect that is visible on the image. It can be identifying some sort of objects. So it depends on your use case. When you train the model, you also need to host the model. That's where the AI model hosting is. So which means you need to take that AI, like binary model, you need to deploy it. You also need to productionalize that one. So we call it productionalizing. So in production, you don't need all those training data or training AI scripts. All you need is a pkl file or some sort of like binary file format, which is representing the train model. You need the Docker YAML file so that you can create some sort of Docker container as an environment for to deploy that model. And you need the scoring file, which is most of the time a Python scoring file. What it does is it takes the model and then it whenever you're sending the data to the model, it goes through this scoring file so that the data transformation happen before the data touches the model. So and the model doesn't give garbage result for that. And then AI model monitoring, that's another important part, because just having a model and deploying a model is not everything. You also need to like monitor this model. Do we need to retrain? Is the model giving good result? How many pods you need to host? Suppose each model prediction takes 1 second. So if you have 500 prediction per minute, so in that case, almost how many? Um, 5 to 10 prediction per second. So if you have a single pod which is doing all the prediction, that's not good enough. You need to have 10 to 15 pods deployed in a Kubernetes cluster so that you can scale. You will be able to do that many number of predictions to that many number of pods, which is the replicas of the model that you just trained. Then model retraining. That's do you need to retrain the model on the new data on a weekly basis, monthly basis, that kind of situation. And AI computation. So when you train the model or deploy the model, you also need to think: is it how the VM will be? Do you need CPU? Do you need GPU? Do you need bigger memory? So that kind of computation is also important in terms of training and also deployment. Then the use case, whether you are deploying the model as a real-time service or a mini batch or something else. And everything is kind of like powered by MLOps. So as I said, for the data, you need to have a data lineage of automation end to end. Same for the MLOps as well. From training the model to deploying the model to monitoring it for retraining it, all this operation needs to be automated and fully uh, like uh, kind of like out of like manual touch, so that you don't need to manually deploy it every single time, unless you run your model on a big batches and once a time, something like that, not a schedule. So you also need to consider that one. So those are the data components, those are the AI components. Then you have platform components. So you need to have data governance in your platform. You need to have multi-cloud support as well, because maybe your data is coming from AWS or Google or some other cloud systems. So can you support that one? Or maybe your client has issues in terms of hosting their data in your certain types of like cloud environment. So you also need to have different types of options for that one. Then you have the data security that also needs to be considered. For AI, you also need to consider the bias, the data balancing, ethical side of the AI, so that the model that you design are not useless or are not like biased. So sometimes some of the tools, like Azure Machine Learning, have this type of feature built in. All you need to do when you're training it, turn it on, and then you will see whether the data that you have used for training is biased or not, is ethical or not, is balanced or not, that kind of things. So these are the from an enterprise level, when you are designing your enterprise roadmap for data and AI, you need to consider those tools like for data, AI, and from the platform. Any questions so far? Otherwise, I'll just gonna move forward. Okay. So when we talk about data, when we talk about we are bringing the data, we are processing the data. So what is happening? You need to have there are like different personas involved in this data ecosystem. So one of the first persona is business leadership. They are the one deciding what is the goal with the data. You cannot just bring the data and then the data is just sitting in your data lake, but you don't know what to do. So you need to set the business goal first. Then the data architect is the one who reviews the architecture, prepare this operational architecture, how the data pipeline will be, where are you going to store it, how the data modeling will look like, so that kind of things, and what is the schema look like from the data source, what type of ETL process you need to do. Those things are decided by data architect. Then the data engineer is the one who designed this pipeline, who write the code to bring the data, the schedule processing, streaming, that kind of things. And then all those ETL steps, extract, transform, and load, is done by the data engineer. Then the data modeler. Data modeler, what it does when the data is available in the a landing zone or staging area, data modeler goes there, create the data model. Sometime a star schema if you want to use a Power BI, sometimes something else. It depends on the modeling of the data and the need of the modeling. So or maybe you need to combine multiple data sources. So that you can come up with some sort of insights. So the data modeler will make sure that you can get all the data regarding that single primary key. So that type of things is done by the data modeler. Then the data visualization and reporting person who is doing the BI, Power BI, Tableau, that kind of BI report for the business. And data analyst and data scientist comes after that, where they start to work on the data when they're raw, but also they work on the data when it's aggregated, summarized, clean, and to find out more into analytics or statistical pattern or designing data science models. So these are the personas for data science, for data ingestion life cycle. And you can see those roles are not a single role who is doing everything. For every single persona, there are different roles. So when you're designing that type of data strategy for your enterprise organization, you need to have that many roles as well available, because you don't want one person to do four jobs. So it needs to be separate one by one from another. So as I said, we there are lots of key components. We need to be able to ingest the data, store, transform, report, consumption, data governance, and exploration. How this looks like, how this map looks like. So that's how this map overall looks like, and I will also show how this looks like in Azure ecosystem. So within this data ingestion, you need to be able to do migration of data from on-premise to Azure or existing platform to the new platform. You need to have options to do real-time ingestion. You also need to have option for trigger or pipeline based on scheduling. When you're storing the data, you also need to have need to be able to store structured data, which is SQL, and you no structured unstructured data. It
Wow.
can be flat files or something like that. You also need to have a data archiving mechanism, hot and cold, because you don't want to keep everything in the hot and it's expensive. That's why. And also, you also don't want to put everything in the cold, because if you need it, then you will have to pay extra money to load it. Data storage zones. So you need to have multiple zones. First one is the landing zone, staging zone, and then the bronze or silver, whichever you call silver zone, because staging is also called as a bronze. And then
May
the
I ask
last
one
one
question,
is
Rahat? It's so interesting. I could forever just visualizing how it's moving. So the beauty of this thing, and
yeah,
I'm just breaking the ice over here, so another
sure,
users can ask the question. So basically, the beauty of this is we don't need to worry about, okay, my data is relational, unrelational, streaming, batch, structured, unstructured, flat file, whatever you get it under the sun, get over here, and we
yeah.
could process that data and get the business value outside it, right? Is it
Yeah.
so amazing?
And the best part is it's so natural. So the moment you put the data or connect the data source to some triggering or pipeline, from that moment to all those individual zone and exposing the data into the Power BI or warehouse, everything happens so naturally through a flow. That is the best part. So if you are running this pipeline at 4 a.m. in the mornings, because you are doing last 24 hours of data aggregation, it will be every day, all the data will be processed, summarized, aggregated before the beginning of the day, so that all the business people can see what is the sales, what are the issues that has happened yesterday,
Great.
or all those things they need to see from a high level.
Amazing.
Yeah,
So that's so good. Like the guys who have only 30 seconds to take the decision, or at most, I would say 2 minutes,
sure.
they could see, okay, you bring up very good value, and that's why these technology are there. They don't need to spend and log in and 2 hours to do their analysis. Everything is doing by data platform or your components, and they could see, okay, these are the problem area which I need my immediate attention, and these are the
Yeah.
couple of things which we are good to go. It's so great. Thank you so much, Rahat. You are amazing.
And one of the big thing is the security, data security. So in an enterprise point of view, how do you guys handle data security? Do you use some third party tools, or within Azure there are like tools that you use regularly? Yeah, Deepak bro, if you want to share.
Me, I'm good for
Yeah.
now.
Okay.
uh,
So
okay.
even like, yeah. Mhm.
Yeah, what was your question? Sorry, I was about to message Ajmain. Ajmain, my name is after Deepak Kaushik, it's Azure Architecture, Azure Architect, Capgemini, Microsoft MVP. So I think you could get rid of two, three Azure Architect.
Yeah.
But that's up to you. So, what was your question, Rahat?
My question was, how do you guys like handle the security part within
Oh
this
wow,
data like platform?
yeah,
Is it like, do you use third-party tools, or within
no.
Azure the tools? Yeah,
That is so good question. As you know, I work with Ministry of Education as well in Saskatchewan, and one of the thing which my CTO told me, like if there is any security compromise, it's not about we are firing. It means getting the legality and all that stuff, because we are dealing with such a sensitive data of kids, their biological information, their grades, their all those kind of very sensitive data as well. So what we did, we use Azure services like Azure
yeah.
Security, which is called ASC. I make a protocol. No code can be checked in if ASC score is less than 7.
Okay,
Apart from that, there is a DDoS implementation as well, and we able to control and give the roles on our back role-based access security and PIM account, privilege access management account. So basically, we restricted the users to that limit where they could have only access they can perform, and that's the reason when I joined that before COVID, and when COVID hit, our data was secure. We able to cater 26,000 students as well without any problem. We were on cloud, so scalability is not a problem as well. So answer to your question is, yeah, it's combination of various things. One of the power client, we implement Azure Lighthouse, which is incredible security and governance
nice for
model.
sure.
And yeah, so it's depend on the need. Thank you so much.
Okay, and do you guys mask all the private information that you were saying, like
In
individual's name or students' date of birth, that kind of information?
Yeah, we did masking on column level and all that stuff as well. Because I don't want, okay, that information, who is, a caretaker, who is biological, and I don't want that information coming to the web and, high school credit score and all that thing, which decide, okay, university admission and all that stuff. So, yeah, we restricted the data to the minimum level. We did,
No.
like, I was not liked by couple of those folks who had been in the leadership ladder too high, and I restricted them. Okay, you don't need this.
No,
So I'm not giving, and they were saying, but we have forever. I said, okay, but you don't need it. So
makes
there
sense.
should be
Yeah.
business reason. Yeah.
Okay, so yeah, we do the same thing as well at Isaac. So all those data or like driving license and everything is completely anonymized and masked as well, so no one can see it, even the date of birth. We also, and when we are connecting one data components with another, we always use Key Vault so that it's secured, the communication, the IDs, and everything. Plus, obviously, we also maintain data access management. Who are the people that has access to the data? That is also like very important. So that's good to know that industry is following that type of like standard. But if we move forward, like for data processing, as I said, there are like so many things we can do, because end of the day, ingesting the data and storing the data one thing, but the goal is to like, what is this data telling us? To do some sort of like summarization, insights, or like some sort of like a pattern analysis. So Power BI is a good tool that we use for business intelligence. But again, there are like so many other tools like Tableau, Colibra, they're also like available in the market.
Yeah.
Data transformation, we have already talked about that. Like we do a lot of like raw transient curation of data. We do data wrangling, data computation, and data recipe as well. And a lot of times what also happen, we also need to share the data. If we are the one who is producing the data through some IoT devices, we also need to share the data through with the third party. So Azure Purview, I don't know if you have used the tool, which is for
Mhm.
data management, data access, data cataloging, has a very nice option for data sharing with third parties, so within the Microsoft domain, and it's completely secure. So that's one of the thing we use. And by the side, we need data and ML ops, BI and analytics, data sandboxing, so that we can do this type of like development step by step, without any interruption. So let's we can quickly discuss about this Azure architecture, just to give the audience some high level information how this overall architecture looks like. So suppose you have data, you can have data from IoT devices. Usually IoT data are streaming data. You can have big data streams from images, audio, or video, something like that too. You can have unstructured data like free text, which it's not falling in terms of like structure, audio, conversational data, video data, images as well, individual images. Then you can have semi-structured data in your platform like CSV, logs, JSON, XML. Then this relational, it can be AWS RDS or relational database system, or or SQL or any other kind. Plus other data services could be Cosmos DB. So if you want to design a data platform which is able to like handle all those like types of data, that is a lot. If you manually do those things, that's why Azure is providing all those tools that we need, the complete tool set. So usually the ideal tool sets are using Synapse Analytics. So Synapse Analytics is not a single tool. It's very interesting what they have done with Synapse. They kind of combined a lot of like tool bases like ADF, then a lot of benefits of Databricks, then the data warehousing. Everything is packaged in a single tool, and they're calling it Azure Synapse. And then it's using any kind of data analytics company to ingest the data, unstructured data, semi-structured, and relational data, through proper
Rahul,
scheduled and event trigger through data
why I'm
pipelines.
saying, why I'm getting the feeling this is my slide, because exactly same I'm going to
Your
demo about Azure Synapse and notebook and streaming and Delta layer architecture. Oh my
So
goodness.
we can
That's
go more
why.
in detail about this. Yeah. So we'll see in 5 minutes. I'm gonna wrap up, but we can also like bring event-driven architecture, like a data through Azure IoT Hub, Event Hub. We can do stream analytics. But the interesting part for me starts here, where we can use Azure Cognitive Services and Azure Machine Learning on stream data, on unstructured data, on semi-structured data, and also on the structured relational data. So this AI services can feed from any type of data sources, and then expose the AI to Power BI or that kind of BI tools, all the AI results. Because end of the day, the only thing matter is what is the prediction that we are making. So I'm gonna jump into like maybe two or three slides just to like show the AI side, because I know you will talk more about the data side. So when we talk about like AI and ML, there is a new role that has emerged last few years, which is data ops and ML ops. So for a traditional application development process, it's called DevOps. So DevOps is the one who implements CI/CD, who also like does collaboration between backend team, front end team, sysadmin, IT team, that kind, because they're the one who maintains the platform, who deploys the production, who hosts the platform in different environment like sandbox, dev, QA, prod, and also they're the one who scale the platform in if needed during any kind of uh, like if you're getting a lot of a new request, your application is having a lot of like new user. DevOps are the one who is responsible for that site reliability, or scalability. So the same thing that DevOps does, when you do it for data and ML, they call it data ops and ML ops. So the similar role, but within the data and AI lifecycle, data ops ensures that the automated data, like automated processing of data, data ingestion, automated data quality checking, data quality monitoring, so that the manual process is kind of like reduced and entire life cycle is automatically maintained and handled. So we also call it like a data, someone who maintains the data lineage. And the ML ops is someone who ensures the model deployment, monitoring, reproducibility, scalability through CT, continuous training, continuous integration, and continuous development pipelines. So a data scientist is not responsible to deploy the model. It is the MLOps engineer is the one who is responsible for this type of like deployment. So for just data, it's a similar thing for AI as well. We need multiple lifecycle personas within this lifecycle. We have the business leadership, data engineer, data scientist is the one who designed the model, developed the model. ML engineer who is working with the data scientist to deploy the model, rewrite some of the codes, prepare the YAML file, scoring file, PKL file. App developer is the one who connects the mobile app or web app with the deployed model through web, some sort of like web interface or some sort of like RESTful API. And the IT operation is the one who is supporting everyone. So when you look at the process, it's a very common pipeline, how an end-to-end machine learning looks like, from loading the data to data preparation, which is your side, all those like data wrangling and data analysis, and then doing the modeling, model development, and then you get into the model deployment part. So all those individual steps happens through this Azure ecosystem. So when you're choosing a platform, you need to like consider one thing. Your platform is not just like giving you a VM and a data source. That's it. No, your platform needs to give something more. Your if you don't have the data for common use case of data, so your platform needs to provide um, pre-trained models. Your platform also needs to provide different types of like notebook, AutoML, ML designer, that kind of like options with CPU and GPU. Plus, your platform also needs to provide model training clusters and inferencing clusters when you deploy the model, so that it's kind of like deployed in hundreds of pods. And then at the end is getting this model testing, monitoring, drifting, deployment, and dashboard options. So from that point, this is the last slide I'm going to cover, and then I will give it to Deepak Bro. If you're designing an AI model, so you have the data, you have processed the data. The first thing that you do in Azure is you do data sanity test, you do unit test. Once you are like sure that the data is good, it's not garbage, it's giving the right format, right? Like the data is of a good quality, then you use Azure Machine Learning to create a workspace, to create a compute, and then publish your machine learning pipeline so that you can train the model. Once you train the model, you evaluate the model. You need to see this model is good or bad. When you decide this is a good model, it's giving good results, it's not showing overfitting or underfitting, then you need to register the model, because you can have hundreds of models for a single data set or use case. For model registering or model management, and that is for another like a big industry problem that Azure has solved through proper model registry, which is we call it ACR, Azure Container Registry. So you register the model where you show that this is the data that you have used, this is the model PKL file, this is the scoring file that you have used, and then AML model management takes the registry, and then deploy the model, package the model first, deploy the model as a web service in ACI. We call it Azure Container Instance, and then expose that model as a web service. So we call this environment staging or QA. So
What
in
is
this case,
ACI, Rahat? What is,
Mhm.
could you explain deploy model web service on ACI?
So what is happening when you have the model and what's supposed the weather prediction? So on a weather prediction model, you are telling tomorrow's date, your location, all the other like related information, and then sending this JSON file to a AI model. The AI model is telling you that tomorrow the maximum weather will be -10, minimum weather will be -5. So this range -5 to -10, this is predicted by the model. So what you do when you have this model, you deploy it before putting it into production, you deploy it into a QA environment or staging, and you call it Azure Container Instance. It gives you the option to take the model automatically deployed in a web interface, deployed in a API as an API, so that
Awesome.
you can connect this API with your web application or mobile application to do this
Okay.
testing, where all you do is send a API request with the JSON as a payload, and response you get is the prediction, like maximum and minimum predicted weather of tomorrow. So that's why, and when you do the testing, you don't need multiple pods or hundreds of like replica. You just need a single replica. That's why they call it ACI. Very easy to deploy. And ACI container is usually one or two core, 1 gig or 2 gig RAM. So it's a very small pod. But you can always have a GPU machine if you need to, if you have a bigger model. Once you are sure that okay, the ACI as a container instance is doing good, you can also do monitoring of your model to app inside. Then you deploy this model. Okay, you are happy with the model result. It's doing good. Its model runtime is good. Latency is low. Then you deploy this model as a production. In production, you need to have multiple replica, 10, 15, 20 pods of the same replica of the same model. In that case, use AKS, Azure Kubernetes Service. So everything is already there. It's very easy to deploy an ACA container into an AKS service. Here, you have a single container. So that same container will be deployed in 10 different AKS automatically. So you won't have to do anything. All you need to do is you need to click create an AKS service with uh, 10 VMs, some sort of like a DSV2 or something like that, 10 VMs. And all you need to say is, I want this much configuration on each pod, and automatically deploy 20 pods of my ACI in this AKS. So something like that. So into the AKS, you will also like have the web version, web as a web service, so that you can connect your mobile with the web application, or with the mobile sorry, you can connect your model with the web application or the mobile application through RESTful API connection. And then for your model health monitoring, there is app inside, and you can always store the data in Azure storage, so that you know how this data performing, how this model is performing, what are the metrics that you're collecting, is it showing any kind of data drift or some other kind of options. If you need to like retrain the model, you can also manage that one from here to push it for retraining with some new data. So this entire process is actually inter ecosystem is maintained by Azure ML. You won't have to do anything, and it's very easy to use as well, and it's completely connected with the Azure data platform that you are going to show now, which can use flat files from the data lake, or even it's not using Azure ML is not using the Delta table yet, but Azure ML has their own feature store options, where you can have AML table. It behaves like a Delta table in this case. So
Awesome.
that's it. My high level overview on AML platform and the data platform, and Deepak bro can take it forward from the data side. But if anyone has any question, feel free to ask me.
Thank
Thank
you,
you.
thank you, Rahat bhai. And till now, we don't have any specific questions, but we have some good wishes from our viewers. We're scrolling some down in later. I think we can directly jump down to the Deepak sir, and he can
Thank you so much. And
continue.
I would like to reciprocate to Rahat. It's such a wonderful session. And I would say, oh my goodness, like every time, so many things to learn. And that is always amazing. And we are going to implement that. Thank you so much. And first and foremost, thank you so much, my Rahat brother, always, standing with me. And we are talking so many things. Our partner in crime, Mehendi, if you are listening us, you do not come in front, so we will discuss with him as well. And to Microsoft Bangladesh community, always we love to share the knowledge with the roots we had, from continent here in Microsoft Tech Talk or Ignite or Dev Teach Conference. Me and Rahat has so many boots on the ground, and we go very oftenly. So thank you. And today my talk is, I would say, I hate to like it's not kind of talk, but real-time problem statement and real-time problem statement. We will talk about that and look over those stuff. So okay, so let me share my slide, and I believe you guys can see it. Okay, that sounds great. So basically, today we are going to talk about Azure Data or Delta Lake architecture. This is kind of, being Azure Center of Excellence lead. Whenever I interact with customer or whenever I interact with some architects, I found there are so many gaps and cracks in their understanding. And whenever I take interview, these are a couple of questions I just discuss with them to look like, okay, are they are really hands-on architect, or what is their understanding, because this is where future is moving ahead. So thank you everyone for joining that. And I will not be discussing about some hypothetical scenarios. It would be a success stories which has been implemented, so that would be helpful for every one of us. So for example, here where we migrated one of the Oracle client into the Delta layer architecture, you might see that, and why we use that, what are the rationale for them. We will cover each and every aspect, or maybe this slide where we have streaming data and why we leverage architecture. So those are a couple of things, and I would like to share, like, the piggy bank would be, you will understand the current technology landscape, what migration option you have to use or how you could accelerate that. And key takeaways would be about adhering to Azure Well Architect framework. So thank you everyone for joining. My name is Deepak Kaushik, and I'm Microsoft Azure MVP. And I always want to talk about, okay, how you leverage technology into your daily life, how you could increase your career in this team, what action you could take to be successful at where you are working, or if you want to move to the developed countries or North America or something like that. Please feel free to connect. I will happy to give those insights as well. uh, you might have come across various my article, more than 1.5 million views. You might have come across my videos as well, on various conferences, and look for various component as well, because I'm contributing since 2008. So this is one of my favorite video where I flew to Seattle at Microsoft DevOps headquarter or Microsoft headquarter and recorded that video after successful migration. And let's get ready for real time scenario. Hang tight. So this is what about Rahat was also mentioning, and I will be taking the pain of data area. So we were discussing, okay, what are the data type? Well, when in 2006 I started my career, usually data is the biggest problem. We were talking about, okay, structured data, unstructured data, file, what not, like so many things were there. So you can focus here, structured or relational data. Now it does not matter a lot. As Rahat also mentioned, this is kind of, whatever the type of data is, our system is so much intelligent, they could move. So earlier, we have to use Azure Data Factory for ingestion, raw storage, let's say data lake. You could use any word over here as well for storage, maybe on-prem. And then we use transformation with Azure Data Factory and saving that data. And then it is available to the end user for Power BI or visualization. Instead of using Azure, you could use GCP, AWS, etc. And basically, if I have to define this slide, I can define in three words: raw, transformation, and store. That's what we have to do. So basically, if you have streaming data, for example, flight, we know flight has streaming data. There, we always look for what is the sound of flight or flight engine, how, what is the temperature, is there is any chances of any breakdown, and streaming data or wind turbines or any streaming data, or you may have batch load. So basically, you could process that, and that is called Delta Lake. What is Delta Lake? Just focus over here, because most of time I found Delta Lake and Data Lake is creates so much confusion. In simple world, Data Lake is Azure Data Lake or GCP or Amazon AWS, which is in real existing. And Delta Lake is open source project that enable building of lakehouse architecture with compute engine. And what is the compute engine? Compute engine is Data Lake, Google Cloud or Amazon S3. So basically Delta Lake always sit over Data Lake. So that is need to understand. Delta Lake don't have its storage, it will use the storage of either of any service provider. So if and excuse me for my these colors choice, and it is quite intentional. If I have to define Delta Lake, I would say Delta Lake is an open source project that allow data warehouse like functionality. That not typically data warehouse functionality. I choose the word like functionality on Data Lake. So Delta Lake is an open source project that allow data warehouse like functionality on the data lake. So that we need to understand, and that is the whole magic over here. So look over the layered data approach. In 2005 or 8 or 18, well, I would say till 16 as well, we have landing data based on source and master. But what changed in data lake? Now it is the bronze DLs, bronze data lake, silver data lake, or gold data lake. So basically it is landing zone is replaced by bronze. In snowflakes we have staging table, row, data vault. Other has almost similar nomenclature. And if you look over this workspace, it has bronze, gold, silver, the same thing, which is from our Azure environment. You could see over here. So bronze is direct copy of source to data, and silver is transformation and bronze data with additional business logic, and gold is kind of gold mine, where you have purest form of data which is available to give to the Rahat for AI and analytics and do all that incredible stuff. But you have to massage that data and bring that data into gold layer. Now question is, hey Deepak, how could we do that? So that is where we are going to do, and I will going to share the demo. So Lakehouse is repository of data stored in raw format. And what are the format, you could say, Deepak, what are the format of Lakehouse or Delta Lake? I would say it could be anything. You bring me the structured data, semi-structured like CSV, JSON, unstructured data, or maybe you could bring me the videos or image or sound. I don't care, or system don't care. They could process all that data. And next question would be, okay, if there is any preference though, I would say, yeah, Parquet and Avro is the preferred format in Lakehouse, but it doesn't mean we could not process another dinosaur ages format like CSV. We could process, but there are some challenges around, progressing and migrating that. What if I don't get satisfactory outcome in QA staging step? Okay, so basically, if you don't get satisfactory outcome in quality assurance staging, then you could transform that data again into QA and save it into test environment, which is called silver in this case. If we talk about nomenclature of a Delta Lake, and save it again into another Parquet file. So you have two Parquet file where which you get the source, another where you transform it and save another version. So first QA file for Najir 01, another Najir 02, and you could save that and progress further. Thank you so much for asking, Najir. It's a wonderful question. And you will get the answer down the time as well. So we have in left side, you could look over the source. We have IoT Hub, streaming data, SQL, CSV, unstructured, structured, Avro, SQL, dedicated SQL pool, whatever data we could think of that is available from source. I need to move that data into the bronze. That is the first thing. That is the landing zone. How could I move that data? I use the copy data activity or Azure Data Factory. And once I have that data available, I clean that data, massage that data, and save into the single in silver folder. And how I could achieve that? With the notebook, with whether that notebook is into the Databricks side, or whether that notebook is into a Synapse side, it does not matter. So we transform that data and save that data into the gold, which is curated, which is fact and dim. And you could fact and dim whenever you look over fact and dim, we our mind connect with the data warehouse, and here you are on data warehouse, which is available to the business for steam, for visualization, for all that stuff. And this is called data transformation. This is A to G, all the transformation happening. And this slide is kind of your Bible, where you could say, okay, for data transformation, how it goes, what are the steps. This slide cover each and everything, and we could take about, okay, transactional data or historical. We are not dealing with the concept of data warehousing earlier, where it is only historical data. So this is these three things, bronze, silver, and gold, are delta lake. And if someone asks what is delta lake, these are the delta lake: bronze, silver, and gold. And this is where we need to migrate. So source data, and now it's let me put some context over here for this demo. So New York taxi data in Synapse is available. We have data available into raw zone and then silver, and we will progress that. And that is on ADLS Gen 2. ADLS Gen 2 is Azure Data Lake Generation 2. And that's what we are going to do over there. So you could see here bronze, silver, and gold, which is means delta lake. And you could see that format is here in Synapse Analytics. I'm going to share you in front of you in a couple of seconds. Now you also see demand fact, which means data warehousing. And you could see, oh, well, it is hierarchical namespacing. That's why it is ADLS Gen 2. It's not a blob storage, because we have hierarchical namespace 20, 21, 22, and you could see the month, 7, 6 or 4th, and then date. So all those details are here, right? So you could look over fact and dim and sales and country or geography, all those tables you could see, and you could figure out that all these data, which we look as a relational data, but no, they save as Parquet file. So that is the gotcha over here. So though at the front end, we could see it is a table relational, but at the back end where it is spotted, it is in compressed format of files, and that we need to understand. And this is saved, like, for example, if I have to read this file, what it means, okay, 11th of January 2019, this is saved. Or let's go for the latest, 22nd of July 2022 at 10:15 a.m., 22nd of July at 11:25 a.m. So these files save with the you know concurrency as well. And you could see the triangle which is here, they are related, like 22/7 and 22/7, and you could see the file. So basically these files are always there, and that help you out. um, Now let me showcase you whatever we talk, so you could connect, and I believe basically that help us a lot to understand. Okay, so basically I'm sharing my screen, and I believe what I need to do, I need to do stop my slide. Okay, okay, I stop my slide, and now I'm sharing window, and I'm sharing you. Da, 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 da. Okay, New York taxi, and here, and I believe you could see my Azure Data Explorer. Storage Explorer. Okay, that sounds great. We are at right place. So New York Taxi Gen 2. What does it mean? We are into data lake gen 2. That's such a wonderful thing. Okay, we have blob container, we have New York taxi. What we see, bronze, silver, gold, like landing zone, transform zone, curated zone. Oh, that's so wonderful. Hey, if we click over there, we could see fact and dimension and all those tables. So that concept is what that is data warehousing concept, and we could see the parquet files all across there, say with the name, with the timestamp and everything. So that give us the feeling and flavor of, oh well, we are into uh, delta lake. All those concepts are with delta lake, and you must be saying, hey Deepak, that's okay. How it look like into the portal. So no worries, let me bring my portal over here, and I believe I have to do stop sharing again. I have to share again, and I could say okay, here you go. So basically, now you could see my New York taxi, which is Azure Synapse, and which was Rahat was also mentioning, like, oh wow, this is a Synapse over there, and we could see serverless and dedicated pool and Apache Spark pool, and we told the compute power is by Apache or Azure or GCP. So that is the compute power. Once we click over there, we could see the different stuff, for example notebook. But let's first take a look over here. We have different data, right? We could say lake data, bronze data lake, gold data lake, silver data lake. How that is formed? That is formed right here. We write the query and we said create the bronze data lake, create the silver data lake, do some transformation here. And this is how this is formed, and this is how you see all those things. Another thing is, Deepak, where is those queries are right here. Queries which we are using in notebook, you could use it, that is here as well, or in Databricks. And further, last but not least, you could transform, run all, and look over all that stuff, and that will be reflected there. So this is integrated runtime. I'm publishing in front of you. This notebook has been published. So that is, here you go. So basically, what if I have to piggy bank now? What we did, we look over the notebook, we look over Azure Synapse, how it look over in the environment, various data, and what are the best practice, which you will ask, hey Deepak, what is the best practice? Best practice should be adhering to Azure Well Architect framework, that is cost optimization, security, reliability, operational excellence, and performance. So this is very real-time scenarios, folks. I think I have 1 minute left, and I able to make it on the time. So I won't take your much time, and I'm going to I'm going to share you again uh, the final slide. But this is what I want to give you the feeling of the real-time scenarios which we have implemented, how we progress, what is the difference between Delta Lake, Data Lake, what is the compute power, what is bronze, gold, silver, how you do all that stuff. And with that note, I would like to say thank you, and I'm all yours with Rahat and my friend as well to take your question. Thank you so much.
Thank you everyone for your nice sessions. Before we end, we have some thank you messages from Mehdi Hassan. Excellent session. Thank you, Rahat Yasir and Deepak. And we have another wish from Kofil. Wonderful session. Thanks to the speakers. Looking forward for the next sessions. So, Rahat bhai, can we end here
Yeah, that was
before?
really nice, and I hope like we will get some questions on YouTube channel. We'll take a look at that this week, and even outside of that, if anyone has any other question, feel free to reach me or Deepak. We are always there to help, and we can have a similar session because I believe like we can show a bit more. Like from my side, a bit more on the AI side. Deepak can also like show a bit more on the like hands-on side, or like the one demo that he was showing. We can discuss by the side, but maybe next week we can have a similar talk. What do you think, Deepak?
Oh, yeah.
Yeah.
I totally agree with you. And Ajmain, at the end of the day, it is the for the benefit of audience. I know it's if you feel interest, the folks has more interest on career building or okay. They ask the Rahat because that has been asked by me in the University of Windsor. Hey Deepak, should I go to AI or data science or cloud migration and all that thing? Secondly, every whenever I talk on APAC region, I was live 7 countries. Deepak, how could we move to what we do? We move into developed country and all that stuff. So those kind of questions, if make interest, we have Rahat who came into University of Saskatchewan, and in 6 years he did such achieve such a wonderful thing, which is kind of dream for everyone, most of us, right? So we don't want to restrict and limit us to technical stuff, but whatever you guys need, you decide and bring me and Rahat. So we will be helpful for technical recommendation, for professional recommendation, how to get job in developed country like Canada, US, Germany, Singapore, uh, all that place, Australia, and we could leverage because we are here to help the community.
Perfect.
Thank you, Deepak. This is so nice from you, and hopefully we'll connect in future. And thank you, everyone. So thank you for that. Until next time. Bye
Thank you.
bye.
Thank you so much, folks. Have a good one. Take care.